A resistor is an electronic component that offers resistance in the flow of current. The practical resistor has a slight shift in its values from the ideal counterparts. Not all the values of the resistor are available in the market. There is a certain number that is chosen and is readily available. If a particular value is to be achieved, then a combination made from the selected resistors is to be used. An ideal resistor follows Ohm's law, which is V equals to I into R. Here V is voltage, I is current, and R is resistance value, and all of them are dependent upon time. A practical resistor changes its value if the surrounding temperature and pressure changes in mechanical dimension. Though there are very nominal changes, yet they differentiate the ideal resistor from the practical counterpart. The resistor value is generally marked on the surface. If the resistor is big, standard values along with manufacturing company seal are also printed on top of it. For a very small resistor, either color code bands or some code is written on top of it. As the size goes on decreasing, the surface area becomes small and reaches a point where it is not feasible to print anything that can be visible to the naked eye. Then the value are written besides the component. Here you can see it is a through 10 kilo ohm through hole type resistor, and since we cannot print on this resistor, it is very small, we have used color coded bands to display its resistance value, which is 10 kilo ohm. Here you have another example. It is an SMD resistor. It is very small and but they have somehow printed a word code saying 1002, which means it is a 10 kilo ohm resistor. Okay, so then we have another resistor. It is also of the SMD type, but it is so small that you cannot print on anything on top of it, so code is written besides it, and when you look into the circuit diagram of this particular circuit which has this component, and you will match this, you will cross reference this number R69, you will find its values written in the document. So moving on, there are two types of resistor. One is fixed value resistors, and then we have variable type values resistor. It is important to consider the power dissipation of a resistor. Since resistor obstructs the flow of current, the obstruction causes a buildup of energy which needs to dissipate. If this energy is not released, then it will burn the resistor or permanently change its resistance value. So resistors use heat to dissipate the energy. For example, here Here you can see, and if I okay, so here in this circuit you can see that we have a battery connected to a series of resistors consisting of R1, R1 and R2, and this is an ammeter. Okay, it is measuring 1 amps of current, and here we have voltage voltmeter which is measuring voltage across R1. So this R2 has a value, resistance has a value of 1 ohm, and this R1 has a value of 8 ohm. And if we go by using, if we implement Ohm's law on these resistors, we have a voltage drop of 1 volt across this R2 and a voltage drop of 8 volts across R1. Okay, and this, and since the electrons flow from negative side to positive side, which is the electron flow of current, uh, when the electrons reaches this 1 ohm resistance, they are uh, they are so obstructed. Okay, so they only allow 1 amps of current to be passed through. Okay, so okay, so a voltage source of 9 volt has connected across the 8 ohm resistor, drops the voltage from 8 volt to 0 volt, blocking a significant portion of voltage, that is 8 volt, and then let's say the current flowing in the current circuit is 1 ampere. So the resistor needs to dissipate around 8 watts of energy. Now you need to select a resistor that can dissipate more than 8 watts of energy, and the next best option is to use a 10 watt resistor. So depending upon the heat dissipation that the resistor has to dissipate, tolerate heat energy, you need to select a particular value of a resistor. There are few resistors that come in. So we have 1 by 8th of an amp, 1 by 8th of a watt resistor, 1 by 4th watt of resistor, 1 by half watt of resistors, and 1 amps of resistor. Then we have 5 watt resistors which can tolerate up to 5 watt with some tolerances. So